Okay, here just to give you an extra examples on the Stokes theorem. So I select a few questions from the past final exam question. Okay, so look at the first one. So we are given a vector function where there is only component I and j, and C is the circular curve. We have a circular curve of the intersection between the plane z equal to 2 and the cone of given by z equal to square root of x squared plus y squared in the orientation counterclockwise when we are looking from the above. Using Stokes theorem, we want to evaluate this one. So that is the first question. So the question 1, we have the case where, so the information provided, we have f is given by x squared plus y squared I, and g is for z. Okay, and we have a curve which is a circle where if we what is the size of the circle? So the circle is actually the intersection between, so we have the cone. So the cone is square root of x squared plus y squared, and the z equal to 2. And the z equal to 2. So that is the cone, and intersect with the z equal to 2. Okay, so that is the z equal to 2. So this is 2. X and then y. So when we are thinking about the curve, so where is the curve? So the curve is this one. So that is the curve becomes the boundary of the cone. Okay. Then, so what is the size of the circle? So we need the radius. So when we obtain the intersection, so from here we have 2 equal to the square root of x squared plus y squared, and then this will give you 2 square. So you have a circle with radius 2 on y-axis plane. So now we know that this one is C is a circle with radius 2, where it is an intersection between the cone and the z equal to 2, and the surface cone. So the C, what is the orientation of the C? It is counterclockwise when we are looking from the above. So when you are standing over here, when we are looking down, so you have anti-clockwise. So sorry, orientation clockwise. So clockwise direction. So clockwise direction. Okay. So now the question is, using Stokes theorem, you need to evaluate, okay, using Stokes. So that is the question. Using Stokes, evaluate the surface integral of curl f dot n ds over the surface sigma. Since they asked for it using Stokes, so we are not going to compute the surface integral, but we are going to compute the line integral, okay, over the curve C, and we have a closed curve here. So we have, on your answer script, you have to obtain this one. You have to compute your result using the line integral for this closed curve. Okay, so f is given. Now we need to get the dr. Okay, so to get the dr, so that is the question. We need to find the vector function of the curve C. So your curve is given by the equation of x squared plus y squared equal to 4. Circle with radius 2. So for this, what is the vector function of the circle? So we know that for this one, the parametric equation is x equal to r cos So I'm using t, and then y equal to r sine t. So r is 2, right? 2 cos t, and then y 2 sine t. How I know? We have to have 2 because we have a circle with this 2, which is r is 2. Okay, so then our vector function now is, because only x and y, so okay, so here x is 2 cos t and 2 sine t, and whether you need to provide the z component or not, so we just provide. But if you look at the f given, there is only ing, so your component k is 0. But whether you put it or you don't put it, so the answer will be the same. But if you want to put that, so we know that this one is located on z equal to 2, right? The circle is located on z equal to 2. So we can just put the z component is 2. Okay. So then dr. So we differentiate to minus 2 sine t, 2 cos t, and then 0 dt. Okay. So then what is f dot dr? So here, what is your f just now? Your f, x squared plus y squared, x squared plus y squared, dx, okay, plus, so your y is 4z, 4z dy, and your dz is 0, right? So you just have dx and dy. Okay, and then because we need to get the in terms of t, so then x squared y squared, so using your equation here, so you got 4, right? 4, and your dx, this one is your dx, and this one is your dy, and this is your dz is 0. Okay, so dx is minus 2 sine t dt. Okay, z is 0. No, z is not 0. So then that's why I told you before, even though the function here is ing, but there is a need for you to obtain your r for 3D. Okay, because just in case we need that to replace the z here. Okay, otherwise you will get confused. So always just bear in mind, even though your vector function is only ing, only 2 components, but for your vector function r for the curve, you should obtain the 3 of them, the x, the y, and also the z. Okay, just in case like this, you have to replace z is in this case not 0 but 2. Okay, so 4 multiplied by 2, you got 8, and dy is 2 cos t dt. Okay, so minus 8 sine t plus 16 cos t dt. Okay, so t is the angle or theta. So we know we have a complete circle from your closed curve here. You have a complete circle, so your t is 0 to 2 pi. But this one, that one is anti-clockwise, right? Okay, so when I read again, so the instruction here, orientation counter clockwise, which means that anti-clockwise. Sorry about that. So I have to correct this one. So it should be anti-clockwise direction. Okay. So anti-clockwise, so it should be anti-clockwise should be that way. And this one should be that way. Okay, so if it is anti-clockwise, so your t from 0 to 2 pi. Okay, otherwise you have to change. Okay, sorry about that. So now we want to compute. Okay, so when you compute that, so we obtain, we have minus 8 sine t plus 16 cos t. When we integrate, sine you got minus cos, cos you got sine, and then you simplify, you got 8 cos t plus 16 sine t, and replace the limit, and finally we obtain this one. Okay, please, when you substitute the value for the trigonometric function, you have to take note that when you use the 0 to pi and you use the pi, or you have to be careful when we substitute the value, because I can see some of you got trouble to evaluate the trigonometric function. Okay, for example, this one. So if you want to use a radian where you multiply 2 multiplied by pi, where 3 point something, right? And you multiply by 2, and then you have to set your calculator to use a radian. But if you want to use the 360, you have to set your calculator using a degree, because sometimes the answer, all the time, what we say for any values, the answer will be not the same. For cos 2 multiplied by pi, 3 point something, or if you're using 360, the answer will be not the same. Okay, so especially when you have you want to compute the basic thing, you cannot leave your answer in this 2 pi or sine 0. You have to evaluate, unless you have for example, you want to compute, let's say in your calculation you have to compute cos 2. Remember 2 here is not degree, so cos 2, you can leave your answer in cos of 2, because cos of 2 is something we are not familiar with. Then you can leave your answer in that form. But if you have 2 pi, cos 2 pi, don't leave your answer in cos 2 pi, otherwise you cannot get a full mark. So because 2 pi is something common, we know that cos 2 pi will give you 1, right? And the answer will be 1. But if your result, let's say you do some calculation and you have cos of 2, and 2 here is radian, so you can leave your answer in terms of cos 2, because cos 2 is not something that you're familiar with. Okay, so you have to take note on that. Be careful when you want to compute the trigonometric function. Okay, so in this case, we obtain the line integral, where the question here asking for surface integral, but since they're asking about using Stokes, so you have to show your work using line integral, and for this we obtain the answer is 0. Okay, so you can have 0, you can have negative, you can have positive value. Right, so that is the answer for the question 1. Okay,